Welcome everyone. Today we will be covering unit tests with O3DE engine, and we will review unit tests for the engine, the project and your gems. Depending on your operating system, I do advise you to use either Visual Studio Code or Codium. For Linux, I advise you Codium, so you don't have the telemetry from Microsoft, but again, it's up to you. You need extensions like the C++ extension, CodeLLDB for the debugging, CMake and CMake tools. If you are on Windows, I do advise you to use Microsoft extensions as well as Visual Studio Code. Microsoft provides most of the extensions that you need. C++ extensions, CodeLLDB, it's the same for both, and CMake tools. You also need a project, and if you have not downloaded yet, you can go to GitHub and clone the repository. So let's start with the engine. In this tutorial we will cover a project-centric development, as in you have the engine and then you create a project that is using the engine. So as you can see, I already opened my source code of the engine in Visual Studio Code, and in this case I already have my CMakeUserPresets. I will leave the CMakeUserPresets on my GitHub and the links down below, so you can use it to adapt to your own project. In this case I have a configure CMake preset, one to configure with and one to configure without the compile commands. On the build presets you then point to one of the configure presets and you state that you are targeting the editor and the configuration profile. Once you open the configure, this is what should appear to you. If this does not appear, go to settings and search for CMake presets. Notice that if you choose never, those options will not appear. So if you have that turned off, you need to turn it either to on or auto. Besides the configurations that you have in your CMakeUserPresets, it also appears the CMake presets of the engine. So when you clone the project, there is already a series of presets that you can use. In this case we are doing our own configurations, but again it is up to you. You then choose on the CMake tools the configure and the build, and you can run both of them. This is the first step to build the source and to make recognize that we have the tests. You do need the PAL trait build test support equals true, otherwise the CMake will skip the unit tests. Depending on your machine, it may take more or less time than me, but this is more or less what you will get initial configuration preset. And the issue that I first encountered was the AzTest runner executable, because we targeted only the editor. We didn't target the executable, because the tests are not executables, they are DLLs, which I took a while to understand how they were used in Google tests. So I added the targets to the AzTester runner, and in this case I only added atomcore.tests. So as a convention, it is the name of the gem dot tests. If you want to test all of them, you need to include all of them in the targets here. For example, since we only want to showcase how to do it, we only added the atom core. The previous one was on Windows, and if you want to try it on Linux, this is the CMakeUserPresets. But again, I will provide some of these CMakeUserPresets for Linux and for Windows. I will try to add more as time goes and as as well as I test more and more. In the Linux I am using jobs equals 4 in order to prevent, because I'm running on a laptop, so I want to limit numbers of CPUs that I'm using. But just to showcase both of the operating systems, I have tested both. I tested the engine on both operating systems, Windows and Linux. This is the result on Linux. So let's jump now for the unit tests on your project. Similar to the engine, again we are reviewing this from a project-centric point of view. So you have the folder that has the engine, and you have a secondary folder that is the project. You create and open your project on Visual Studio Code. I also have already a series of gems inside it. So what I'm doing right now is navigating into my bin profile, and I'm searching for my one of my gems, as well as the executable for the game. Now I want you to notice that my gem is called Entities 088 version 3, and then the .tests means that I already built that gem and it creates a DLL. Again, it does not create an executable. You need the AzTest runner to read the DLL and the tests that are inside it. In order to exemplify how to do this on the project, I copy-pasted the CMake presets and called it CMakeUserPresets. The reason why I do not edit the CMake presets that come with the engine and the project, it's because different developers may have different configurations and different operating systems, so it's a good practice to use the CMakeUserPresets instead, because that will be unique to only you as a developer. Even if you do not use it, it's considered good practice. Once I created my CMakeUserPresets, again I do something similar to what I did in the engine. I state that I am using the Visual Studio generator. In this case I'm still on Windows. I state the binary directory as well as my O3DE packages, because I'm not using the same directory or the default directory. One configuration that builds the engine, and another configuration for the compile commands. When I build, I'll point to one of those configurations, and in this case I will target the project game launcher, the editor, and the entities.tests. The reason why I'm pointing to the gem already, it's because all of your gems are like babies. They depend on a project. You cannot build directly a gem and then try to run it or run the tests. You always need the project. So I left here the entities 088 version 3 to remind you that all of your gems need to be built on your project. You need to be mentioned there. Even if you want to test it, you need to leave that behind. The current error displayed here is due to the gem.tests, or the DLL of tests, still has a flag turned to false. In the next section we will see how to turn that flag into true, which is in the file palwindows.cmake, and the building of the project targeting test DLL will work. So for now we'll just remove it so we can build the project and continue. The tests should reveal if you are targeting already a gem that has unit tests inside it. You can also debug your code from your project by using a launch shot-asn. In this example, I configured for two executables: the game launcher.exec and the editor.exec. What is the difference between these two? The game launcher is when you're trying to run the game. So let's assume that you already created the executable and you want to debug in runtime. So you debug with that configuration. If you want to debug with the editor or through the editor, you choose the second option, which is targeting the bin profile editor.x. Both are useful, so I also add these two to the shared files in the GitHub. You might need to edit or adjust it to your needs, but both are working. And I will showcase it how to use the editor in this case. By pressing the debug with the editor.x option selected, it will execute the editor and will allow me to use the editor. And by setting a certain breakpoint, in this case it is a breakpoint inside one of my gems, I can showcase it that the debugging and the breakpoints are working. Let's review now the unit tests for your custom gems, or unit tests for your code, so to speak. In my case, for some reason the pal trait build test supported was not passing through, so I had to comment it out. You also have to go to pal Windows CMake or Linux if you are in Linux, and make sure that your test support is set to true too. Otherwise you also have to comment out the condition. This is enough to allow your test DLL to be recognized and be compiled or be built. In this case, I open Visual Studio Code in my gem folder, and my idea was to work only on my gem code. I wanted to have some kind of isolation of my code when I'm working only on that gem. I took a slightly different approach when coding to the gems. Instead of using CMakeUserPresets, I also use tasks. In this case, I'm only testing rapid JSON and serialization and deserialization of entities. All I'm doing is serializing a class into a JSON and vice versa. Then I wrote a series of methods on each class in order to do that, and they cascade and create the neat little JSON that we are all used to. The hierarchy that I've used, or the example that I used, is the common one in video games, which is a character, and the character can have default items or default spells or spells. He also has an inventory, a backpack, and so on and so forth. So I'm just exploring both unit tests and as well as what can I do with the serialization and deserialization using rapid JSON, which I advise you to use on O3DE engine. The AzTest runner is expecting Google tests or G-test, which is a library for conducting tests in C++. So you have to use the same conventions or the same rules as Google testing. In your gem CMake list, you can also print the build test supported, or the flag or the boolean if the test supported is active or not. This is a good way to track during your configuration and build if you are targeting the tests or not. Once I made all of my entities that I wanted to serialize and deserialize to use on my prototype, I then created a CPP file. Notice that this is in a specific folder called tests. And in your CMake list, you are going to include that folder on private. Please be sure that you add this on your tests, not in any other model, because you don't want to expose these tests to your game or public or interface or so on and so forth. These are specifically for development. And these are some of the unit tests that I wrote. You just need to follow these more or less this rule, which is a test, then you give it two names, being the second the name of the test, and it only has an assert, which I am, in this case these unit tests are just checking if I have if it is serializing correctly, and then deserializing again and checking if the initial values match the deserialization. Nothing complex. In your gems or your unit tests, you can try whatever you want. The DLL that creates it's usually called, or as a convention, is the gem name .tests, and that file should be inside the project, the build, the operating system that you are using, bin, the target that you're using, which is profile, and then you can search for your gem name .tests. Obviously I already configured and built, but once you have done it, that's where your DLL of tests should appear. As I mentioned, I'm not using CMakeUserPresets on my gem. I wanted to do something different. I did not want to build my project with CMakeUserPresets. I wanted to use tasks and only configure or only build my tests or only debug my tests with a specific task, instead of CMakeUserPresets, which does everything all the time, and you sometimes lose a little bit of time just waiting and looking at the monitor. The way you can use the tasks once you have created them is like this. You open CMake the same way, you press the run task, and all of the tasks should appear there. In my case, I like to place a number, so I'm not lost, or I don't have to read the entire details or the entire display name. By giving these numbers, I know that from low to high numbers is like configure, build, run tests, search for tests, or debug. And that's more or less how I configured my task shot-a-sun form. Again, this is only for my gem. And while I'm on Visual Studio Code open and with my gem folder open, I can build my engine, or I can build my project, or I can build just the gem. So I have full control from inside this folder. Again, it is up to you if you want to go back to the project and then build it there, or just do everything from using the tasks. So as an example, I'm going to show you what happens when you build a task and that task is just building the gem. You just open CMake, run task, and choose that task. As another example, you can also run the tests with a task. So again, you do not need to open the project again in order to run those tests. You can also see the results of the test in the last test.log, which is very useful. It is inside your project, build, Windows, testing, temporary, and then test log. This is because the Test Explorer wasn't giving me enough details, so I wanted to know how I could review what test was failing or what was giving the results. I also added another task in order to list the unit tests of Google tests, because I always expected the unit tests to be in Test Explorer, and it always shows only one test. This is because it is a CMake test. The Google tests are inside the CMake test. That's why it wasn't appearing. So if you do manage to figure out how to display them on Test Explorer, feel free to leave a comment down below. But since I failed to do that, I am providing the feedback that I find useful, and in a way you can also use it. Besides that, you can also debug your gem or your tests. In this case, I'm going to show you how to debug only the tests and see how much, in my opinion, how much better it is to debug the unit tests through your gem, because you do not need to open your engine or your project. You can directly debug your tests in just a few seconds. So I will also leave this launch JSON in my GitHub, so you are free to use it and adapt it to your needs. As I mentioned before, this is the test explorer, and you can see that even if I have multiple Google tests, it only shows one. In case of the engine, it is showing all of these tests, but all of these tests are CMake tests, and inside each one of those CMake tests you have many more Google tests. So I needed more granularity, so that is why I'm advising you to use the last test log, which will provide you just that. All of those tasks that I showed before, again, you can use them and even increment it or adapt it or expand to your needs. As promised, I will leave these configurations in GitHub. You will have to adapt them because I have certain configurations or certain directories that are custom. They are not using the default directory or the O3DE engine, so to speak, is advising, so you do need to adapt them. I think that the Windows, I did leave all of the tasks and CMakeUserPresets for Windows, and for Linux I haven't completed everything yet, but again, you can just adapt them to your needs. So these were the basics of unit testing with O3DE engine that I wanted to cover. So I hope you enjoy it and it helps at least one more person. That is it for today. See you in the next video.